Hello and welcome. In this video, we are going to be covering how to draw the shear force and bending moment diagrams for the simply supported beam with a point load. By the end of this video, you'll be able to draw the shear force and bending moment diagrams for the beam with an applied load and use this knowledge to solve similar problems. Let's start by defining what shear force and bending moments are. Shear force is the force that acts perpendicular to the longitudinal axis of the beam. It tends to cause the beam to slide or shear apart at a particular section. It is denoted as F and can act upwards and downwards. A bending moment happens when there is a distance between the shear force and the point in which the moment is acting. It tends to cause the beam to bend about the point and is calculated by multiplying the force by the distance. It is denoted as M and can either act clockwise or anti-clockwise. The shear force diagram shows the variation of the shear force along the length of the beam. The vertical axis represents the magnitude of the shear force, and the horizontal axis represents the length of the beam. The diagram is typically shown with the positive values of shear force above the horizontal axis and negative values below the axis. The bending moment diagram shows the variation of the bending moment along the length of the beam. The vertical axis represents the magnitude of the bending moment, and the horizontal axis represents the length of the beam. Again, the diagram is typically shown with the positive values of bending moment above the horizontal axis and negative values below the axis. Now, let's work through an example of how to draw the shear force and bending moment diagrams for a beam with a point load. If we look at the beam, we can see that it is 1 metre in length and has a 250 Newton load applied 0.4 metres from the left. The beam has supports at either end labelled RA and RB. RA is equal to 150 newtons and RB is equal to 100 newtons. If you need help calculating these, please watch our video on how to calculate the support reactions of a simply supported beam with a point load by clicking the link in the top right of the video or following the link in the video description box. To draw the shear force and bending moment diagrams, we must make imaginary cuts along the beam where we are going to determine our shear force and bending moments. In order to calculate the shear force and bending moments, we will take into consideration the forces to the left of these cuts. It must be noted that as our beam is in equilibrium, the total forces acting on the beam are zero, and the total moments are also zero. We will begin by drawing the shear force diagram. First, we need to cut the beam at sections where we want to determine the shear force. It is important that our imaginary cuts fall at the same length as the point load. So in this example, we will cut the beam at 0.2 metre intervals. When x equals 0, the only forces acting on the beam is the 150 Newton reaction force RA, so the shear force at x equals 0 is positive 150 on our diagram. When x equals 0.2, the 150 Newton reaction force RA is still the only force acting to the left of the cut. The shear force remains as positive 150 on our diagram. When x equals 0.4, we have the introduction of the applied load of 250 newtons in the opposite direction. So the shear force becomes 150 minus 250, which equals minus 100 newtons. When x equals 0.6, the 150 Newton reaction force RA and the applied load of 250 newtons are again the only forces acting to the left of the cut. So the shear force is again 150 minus 250, which equals minus 100 newtons. When x equals 0.8, it is the same as the previous two scenarios. So again 150 minus 250, which equals minus 100 newtons. And finally, at x equals 1, we have the introduction of the 100 Newton reaction force RB in the upwards direction. So the shear force is now 150 minus 250 plus 100, which equals 0 newtons. By connecting the dots, we get the finished shear force diagram for our beam, which looks like this. The diagram shows how the shear force acting on the beam changes along its length, and also identifies the point of maximum shear stress when the line crosses the neutral axis. Next, we'll look at how to draw the bending moment diagram for the same beam. Once again, we will be making cuts at 0.2 metre intervals and analysing the sections of the beam to the left of the cut. When x equals 0, the only force acting on the beam is the reaction force RA, but as it has a distance of 0 metres, the bending moment is equal to 0. So our bending moment diagram starts at 0. When x equals 0.2, the reaction force RA now has a distance of 0.2 metres. So our bending moment at 0.2 metres has become 150 times 0.2, which equals 30 Newton meters. When x equals 0.4, the reaction force Ra now has a distance of 0.4 meters, and we have the introduction of the applied load of 250 newtons. Although at this point, the distance of the 250 newton load is 0 meters, so the bending moment of the applied load is equal to 0. Therefore, at this point, our total bending moment is 150 times 0.4, which equals 60 Newton meters. When x equals 0.6, our bending moment is 150 times 0.6 minus 250 times 0.2, which gives us 40 Newton meters. When x equals 0.8, our bending moment is 150 times 0.8 minus 250 times 0.4, which gives us 20 Newton meters. When x equals 1, our bending moment is 150 times 1 minus 250 times 0.6, which gives us 0 Newton meters. By connecting the dots, we get the finished bending moment diagram for our beam, which looks like this. The diagram shows us that the point of maximum deflection is at 0.4 meters. And that's it. We hope you enjoyed this video showing you how to draw the shear force and bending moment diagrams for the simply supported beam with a point load. We hope you found this video useful. Please check the channel for more.